Your body is literally made of stars that died millions of years ago. Every atom in you, from the carbon in your skin, the oxygen you breathe, to the iron in your blood, was once part of a star that exploded violently in the distant past. Crazy, right? In the very beginning, when the universe was born around 13.8 billion years ago, only light elements like hydrogen and helium existed. Back then, there were no heavy atoms like carbon, oxygen, or iron. Then, around 200 to 400 million years after the Big Bang, the first generation of stars emerged from clouds of hydrogen and helium. These stars were massive, sometimes thousands of times the mass of our Sun. But their lives were short, only lasting a few million years, compared to our Sun, which at 4.6 billion years old is only halfway through its lifespan. These first-generation stars, known as population 3 stars, were unique because they were made almost entirely of pure hydrogen and helium, without any heavy elements like carbon, oxygen, or iron. As these stars burned through their hydrogen fuel, their internal pressure and temperature increased, allowing helium to undergo nuclear fusion. This process created carbon and oxygen. If the star was massive enough, fusion continued, forming heavier elements like neon, magnesium, and silicon. Eventually, silicon fused into even heavier elements like sulfur, argon, calcium, and finally iron. So, what exactly is nuclear fusion? It's the process where two light atomic nuclei combine to form a heavier nucleus, releasing a tremendous amount of energy in the form of gamma radiation. This energy comes from the small difference in mass, which is converted into energy according to Einstein's relativity principle. Nuclear fusion is the primary energy source for stars and the foundation for experimental fusion reactors like tokamaks and stellarators. For fusion to occur, atomic nuclei must get close enough to overcome the electrostatic repulsion between their positive charges. This requires extremely high temperatures, so the nuclei have enough kinetic energy to collide. In the Sun's core, temperatures reach millions of Kelvin. High particle density is also crucial to increase the likelihood of collisions, and the plasma must remain in these conditions long enough for sustained fusion to happen. Because fusion demands such extreme temperatures, it can only occur in objects with enormous mass, like stars. The immense gravitational pressure in these stars raises their core temperatures to the point where fusion can take place. Now, back to population 3 stars. When these stars produce iron, it marks the end of their fusion process. Why? Because fusing iron doesn't release energy. Instead, it requires energy from the outside. As a result, when the core fills with iron, radiation pressure can no longer counteract the star's own gravity. In just seconds, the star collapses and explodes as a supernova. The debris from these explosions spreads across interstellar space like dust carried by the wind. It takes millions of years for these particles to clump together again, drawn by gravity into new clouds of gas and dust that eventually form new star systems, like our own solar system. The remnants of long-dead stars slowly mix together, creating planets, asteroids, and ultimately, life on Earth. Our Sun itself was born about 4.6 billion years ago from the remnants of earlier stars. So, in a way, we are literally children of stars that no longer exist. A star that exploded maybe 5 to 7 billion years ago, long before Earth even formed, provided the elements now flowing through our blood, forming our bones, muscles, and even our thoughts. So, the next time you stare at the night sky, remember, you are a part of it. We are all made of stardust, literally. We are part of the cosmos. We were created by the cosmos itself, and one day, the atoms in our bodies will be recycled once again. Millions of years from now, the carbon in your body might become part of another living being. So, if you've ever wondered, where do we come from? The answer lies in those ancient first or second-generation stars that died long ago. Those stars had to die so we could live. And most importantly, no one designed or created us. We are purely the result of a cosmic accident.